Hi students, today I am going to teach you mechanical properties of fluids. See, fluids, anything which flows is known as fluid. Here example is liquids and gases. So liquids and gases, they flow. Next is pressure. The formula for pressure, you know, pressure equal to force per unit area. So P equal to F upon A, and units of pressure is pascals, or we can also write Newton per meter square also. And now density, the formula for density is mass upon volume, and formula for density is mass rho equal to m by v, and units of density is kg per meter cube. And we'll go to the standard values of density. The density of water is 1000 kg per meter cube at 4 degrees centigrade. This is for the fresh water. I'm not speaking about the sea water. The sea water density is different. Now density of mercury, which is a standard value which we use in barometer also. So 13,600 kg per meter cube. And density of air is found to be 1.29 kg per meter cube. Now these are the standard values. We have some more standard values for sea water and for ethyl alcohol and all, but these three are very important. Now come to Pascal's law. Blaise Pascal, from he's a French. So this man, he found out like pressure exerted is same in all directions in fluid at rest if they are at the same height. Okay, if they are at the same height. Suppose you are applying, suppose there is a object or there is a body in water or in a fluid, and the pressure exerted is same at all points. So the condition is they should be at the same height. The body should be at the same height. So F1 by A1 equal to F2 upon A2. Okay, now we will discuss about variation of pressure with depth. Before going to that, I would like to discuss about pressure in fluids. So pressure formula is given by P equal to, that is P is equal to F upon A, force per unit area. And now we know that force is equal to MA, but instead of taking MA, I am taking mg here, and area is as it is. I am multiplying and dividing by h. After that, I get here area into height is written as volume. So mass by volume, and gravity into height. So mass by volume is density. So the formula for pressure in fluids is known as P is equal to rho gh. Now we have next concept, that is atmospheric pressure. Atmospheric pressure means pressure exerted by the gases present in the atmosphere. There are so many gases present in the atmosphere. These gases are exerting pressure on the surface of the earth. Okay, on you, on me, everywhere, and everywhere it is gases are exerting pressure on the surface of the earth. How much is that value? We can find out. P is equal to rho gh. So we have the formula P is equal to how much? 1.29 into 1.29 is the density of the air. Then we have 9.8. 9.8 is the gravity value, and 0.76. 0.76 is the height of the mercury column in a barometer. That we will discuss. The next topic is that one. So when we from there we get at sea level, this is at 0.76 centimeter, 76 centimeter sea level, but when we are writing in terms of meter, we write 0.76. So the formula for pressure is 1.01 into 10 to the power of 5 pascals, and we also write P is equal to 1 atm. Now, so quickly, the pressure in fluids is given by P is equal to rho gh, and atmospheric pressure is value is 1.01 into 10 to the power of 5 pascals. Next one, variation of pressure with depth. Suppose a person is swimming in the water, and we want to find out what is the total pressure acting on that person, due to the air as well as due to the water. Now this is the surface of the water. A person is swimming in the water. Now maybe at a height h from the surface. Okay, from the surface at a height h. Now P naught is the atmospheric pressure. The atmospheric pressure we already know. This is the value. So P naught is the atmospheric pressure which is acting on the surface of the water, and water is also having, water up to height h, it is also having some pressure. Okay, so it is having a density, it is having gravity, it is having height. Because of this also it will act some pressure is acted on this person. So there are two. This pressure is known as gauge pressure. This is the atmospheric pressure and this is the gauge pressure. So there are two pressures. So the total pressure is, so P naught is atmospheric pressure, Pg is gauge pressure, and Pa is the absolute pressure. The total pressure acting on this person is absolute pressure due to the water as well as due to the air. So Pa equal to P naught plus Pg. So So if you want to calculate, if you want to calculate the total pressure, how do we write now? Absolute pressure equal to atmospheric pressure is 1.01 into 10 to the power of 5 pascals plus rho gh. Okay, just substitute the value. Just substitute the value, we'll get this answer. Okay, so suppose if the person is at a height at a like maybe 2 meters from the surface of the earth, just substitute that value. Density of the water value, that is 1000 kg per meter cube, and gravity value. If you substitute, we'll get the total pressure exerted on the person due to the water as well as due to the air. So that is why the divers when they go in the water, like maybe deep into the water, they have to wear the suit, the diving suit, because as they go down deep into the water, the pressure will be more and more, and it is very difficult for them to breathe, and even they were not able to breathe properly, and there can be a fatality. So fatal death may be there. So for that reason, these people will wear a diving suit, and they go in deep into the water, so that because of the pressure of the water, they don't get they don't get crushed. Okay, so can quickly take a screenshot. We can go to the next one. Now we will discuss about the Mercury Barometer and Nanometer. So here we have one torr. These are the three values. Like we found out the pressure values or units of pressure. One torr value is 133 pascals. One bar equal to 10 to the power of 5 pascals. And one ATM, one atmospheric pressure value, is 1.01 into 10 to the power of 5 pascals. Next is Mercury Barometer. Mercury Barometer is a device which is used to measure atmospheric pressure. This was devised by Evangelist Torricelli. And here what exactly we use? We use mercury. We use 1 meter long tube, and there is a vessel. We take the tube, fill it completely mercury up to the brim, and invert it into the vessel. When you invert it to the vessel, the whole mercury should come down, but that is not happening. So here, if you look at these points, what is happening here? The atmospheric pressure is acting and on this fluid, and it is not allowing the fluid to come down. Atmospheric pressure is acting on the around the tube. As I told you, everywhere there is some pressure. That is said to be atmospheric pressure. That is acting on the fluid and mercury, and not allowing the mercury to come down. So there is some fluid already remaining in the mercury. In the mercury is remaining in the tube. So how much it is at sea level? It was found to be 76 centimeter. So use the formula V is equal to rho GH. P is equal to 13,600 into 9.8 into 0.76 meters. When you multiply, we get the answer. P is equal to 1.01 into 10 to the power of 5 pascals. What if, the question is, what if this is the pressure? Okay, this is the atmospheric pressure. So which we already wrote before this also. Now, what if in the place of mercury, if I replace with water? If I replace mercury with water, so what should be the size of the pipe? So when we substituted the density of water, which is 1000, and gravity is 9.8, and we substituted P value as 1.01 into 10 to the power of pascals, we found that the height of the water in the tube is around 10 meters. Means the meaning is, if you are using a water barometer, then we need 10-meter long tube and a big ladder also. Okay, so that is about mercury barometer. Next one, manometer. Manometer is a device which is used to measure the gas in a container, pressure of a gas in a container or a pipeline. Now there is a chamber, and we have connected the pipe to it, and we want to find out the pressure. So this is the P is the pressure, and because of the pressure, when we connected this U tube to a pressure chamber, what happens? The pressure is acting on this point A, and because of it, the fluid, whatever we have taken, is moving up. It is pushing down, and the other side it is moving up, and because of which there is a height H. There is a height H. And what is this pressure? Pressure here acting is P0, atmospheric pressure again, on the other end of the mercury or the fluid, whatever we have taken. So now just substitute H value here, then we will get the total pressure in the gas container or the gas or in the gas pipe. Okay, take the screenshot so we can go to the next topic.